Okay, back with another coding session, back with Bangalang, and moving through our lists of features to really like hone in the language. It's really turning into something that I'm starting to feel is more pleasant to use, but we still have a little bit to go, I think. I went through the code just now, had a quick look through and added a few more points, mostly around types. And then also I would like to make our assembly nicer, but I've put this in there surgeon. I don't think we need to do that anytime too soon, but that would be a nice thing to do. Actually, that's almost more of like a cleanup thing. So I think this is what I want to tackle today. I think we should be able to get through this without too much trouble and then maybe tackle some other smaller things, maybe some of these new things I found. So, any statement as pre, post, and for loops. Before we actually get to that, there's a couple of why I'm here is because there's a couple of tiny things that I wanted to change. I realized that this here, changing a script to a compound literal, is only really relevant in the context of an assignment. In this case, it's the right-hand side node. It's only really relevant in the context of an assignment. Anywhere else where we have a right-hand side expression, we should already have a compound literal. So I just wanted to move that up there. And one other thing that I noticed was this here. Procedure is like this kind of built-in special type, and I don't think we want it to be an identifier. There's not really any point. Yeah, if we run that, we see that everything's fine without it. So that's that. Now our for loop, improving our for loop. The other thing I wanted to do was make the brackets optional. I've got here to remove them from the if, but because technically if we remove them, we can still use brackets because expressions can have brackets. And the if just has an expression here, right? So we could use the brackets of the expression. But just for consistency with the for, I'm going to leave them in and make them optional. Yeah, because I don't want to have to use brackets around these things. I'm kind of used to it now with Odin. So you have like this kind of thing with no brackets. And I kind of like it. So we're going to do that. So let's upgrade our grammar to reflect these changes. So the most basic thing is that these brackets are going to be optional now. Where else do we have brackets? Oh, here's a bracket for that expression. Here's a closing bracket, and then there's another set of brackets for the else if. I think that's all of them. So these two are optional, that one's optional, that one's optional, and these two are optional. Yeah. And the other thing is to make, instead of an assignment, I'm going to make these statements. Because why not? Why not have them a little more flexible? I don't think it'll make things too much trickier. The one thing that is a little bit tricky about them though, is that a statement could be a right-hand side expression. And because we specifically want a right-hand side expression here, it does make the parsing kind of complicated if we allow one here as well. We probably could figure it out, but I'm not going to. Instead, I'm just making this notation up as I go. But here I'm saying it's a statement and it's not a right-hand side expression. So we don't allow right-hand side expressions here. We allow them here because that doesn't introduce any trouble with the parsing, but here it does. So we're just going to do this for now. We'll try that out. Maybe later on we might change back to assignments if we discover that this is kind of trouble. But I thought, why not? Why not allow like any kind of statement. I don't see too much harm in that. So those are all the grammar changes, I think. So it's mostly parsing we're talking about here. Parse if for return scope. I wanted to move this scope down below here. Like all the things that this can possibly parse, I kind of like them to be below. I think I realized that also here, because I'm so picky, and here I also wanted to move them so they're all in the right order. I mean, this is going to be moot eventually because I'm going to split them out into their own files, but right now I'm very picky, so I like them to be in order like that. Okay, so for our if statement, the only thing we changed is we made these brackets optional. I'm going to make a Boolean here, and then I'm going to say if we pick a token and we find that the type is, what is it, opening bracket, then we'll consume it and we'll set that to true to say that we're doing brackets. Because we need the matching bracket, right? This closing one. But we only want to have a matching bracket if we started with a bracket. So we either have both of them or neither of them. That's how it should be. So only if we had an opening one do we need a closing one. That's the idea. And then this is the else if. So set that to true. And then we want something like that down here where we close. Whoa. So that there should mean that we have optional brackets in our ifs. I'm going to steal this because we will need it in our for loop. We've got this bracket. This time we can just call it bracket. Maybe it's better with plural. And so yeah, we've got the opening bracket and then down somewhere here, the closing bracket. Like so. Okay. So we have optional brackets for if and for. We have this terrible condition here. This kind of manual way of determining whether we're talking about an assignment. Identify a colon. Which is not all assignments need to have a colon. So I'm just kind of lucky that it's worked out for me so far, but it's really not nice. So what are we going to do here? So something that we introduced, I guess, after this, we used to have a few things like this, but it's kind of been resolved now because we can try to parse something and see if we succeeded or not. In this case, we're going to parse a statement. So pre-statement node, and then also we get a pre-statement OK, because we're not all returning, so we can get the Boolean to see how we did. We also need to have our own stream, like so. So there's a stream that we can put in here, and I think we need a pointer to it. So now we've attempted to parse a statement. So if we succeeded, we can get rid of this done condition. We can say if we succeeded, then, well, we already have the pre-statement node. So we do that. And we also need to then update the main stream to reflect this, to reflect how much we parsed. Like so. Now the other thing was that we don't allow right-hand side here. So we need to verify that it's an assignment. I think back here actually I noticed, yeah, so this here is kind of like saying it must be a right-hand side expression. We want the opposite of that, so we want the same kind of condition. But what I'm going to do is I'm going to go to our AST and add a list. So this will be statements, AST node type, and we're going to put all these in like so, and of course, we need to put them in the right order. And we're going to add scope as well, because that's another one. Previously here we did not have scope because scope was kind of valid to come in here, but now that we change it away from scope anyway, it should be fine. So then we should be able to go slice.linear search on this type and say, like, if it was a statement, well, that's not valid. Like so. While we're at it, I just want to check up on some of these imports, because I think some of them were a bit dodgy. Just put them in alphabetical order, but that's not the main thing that I was worried about. Here it is. That's stupid. I don't like it. There we go. Better. Oh, I turned off the tests. Of course I did. Okay. So, where the hell were we? What the hell were we doing? We were in parsing, I believe. That's right, we were parsing a for loop. And we did this. That's right, and now we wanted to know, just like we did here, whether it's a statement or not. So now we're looking at the pre-statement node, and we need slice to be imported. Yeah, so we need to know that it's a statement before we come in here. So that by saying that it's a statement, we're saying that it's not a right-hand side expression. It's a bit unfortunate that we parse again, because if it was not a statement, we've basically already parsed into here the right-hand side expression that we could use here. But just for simplicity's sake, like this is the first part, this is the middle one, and this is the, this is the third one. It's just kind of easy to read. Performance-wise, it's not as good as it could be, but I think it's fine. So what were the points we were trying to do? I think that's basically it. So let's try run that and see what happens. Did have a cup of tea, but alas, it is finished. Come on. How are we going? The fact that it hasn't crashed yet bodes well. Yes, okay. Yeah, I feel like if it's getting through the tests, if it gets through the initial tests, all the for loop tests and stuff, then it's probably good. Okay. So there's a few things I want to search for and replace. So if we find like if space bracket, interesting. Oh, because that's got to be or, yeah. And I guess this is or is something as well. Yeah. Okay. So we'll do a control replace without bracket. Well, I guess maybe we shouldn't do a control replace because we kind of need to take away all of them, but maybe as far as tests go, maybe I'll just add a test that does have brackets. We won't add too many of them, but we'll add some of them just so that we are still testing a variation with brackets. Maybe we'll do one that's got else if as well, like this. The else if true scope has brackets, like so. Just take away all of these brackets. And from the for loops also. So this is the kind of situation where I probably would have brackets, because it just makes it a bit clear where this statement starts. So if you take away this bracket, it's kind of like, holy shit, what's going on here? It'll be valid and work, but it just looks a bit nice with brackets. So we'll leave brackets on there, and maybe I'll put brackets in the name, I guess. Let's have a look here. So we've got 3 tests. Yeah, 3 in the test, that's probably right. Okay, now in the example code, can take away these. And in the standard library, we can take away from that for loop too while we're at it. Okay. So if I check again, yeah, that looks good. Okay. What about for loops? This one we wanted in the tests. Clean this one and that one. And this is tokenization. This is Odin code, so we won't worry about that. Probably same kind of reason that we saw before with ifs. So that's all of those. And then I want to search for +1 in Bangalang code. Well, not specifically, I guess it could be in tests, not test ASM. Tests.odin. Yeah, it's coming up with a lot of assembly code here. So let's do just Bangalang code, I guess. So this here is an assignment. This currently, I'm actually thinking to change this, but currently this is a right-hand side expression, which is why I couldn't do this here before. And now I can. Which is just, whoops, I should probably do the whole thing. And that one is fine. Okay, yeah, I don't think I missed any. And was there any like -1? No. Cool. So let's try that again. I think all the, everything should be great. And if it is all great, that means that this is basically done, which is awesome. It's only taken us 20 minutes, so we've done pretty well. I do think this is a pretty big change. Yeah, because we have to like move around some assembly. I really kind of screwed it up before. This bit here, it says review precedents, but it's actually something more difficult. So I think we might move on to some of these things. Ooh. Expected opening curly bracket found plus equals. Standard lib 123. Okay, so it seems to be parsing like just this. And then saying that there should be an opening curly bracket. Okay. So when we parse our for loop, it's that's why. And actually, I thought we'd done it so quickly. And the reason that we'd done it so quickly is because we hadn't actually done a lot of the work. We just kind of decided that we were done when really we were totally not. Because we have to go to type checking and to generation and update to this new setup. So like in here, for example, we need to type check a statement. And we can't do that, right? So what we actually need to do is the same check as we did here. Not that. And we use the child node, but we do it like that. And this one is also type checking the statement. So this time we can't do it based on the type really, because this statement here, which is the body of the for loop, could be like anything. So I think we basically need to say like, if this child node is not the last child node, would it be something like that? Let me put it in here and then think it through. So the length of children is greater than child index. Because right now I've grabbed a node at an index and then I've incremented the index. So this is the index of the next node. Not the current node that we're going to check, but the next one. And if that one is the length, no. So if that one is the length, that means that this node is the last node. But if the length is greater than child index, that means there's still another node to come. Okay, so I think it's that condition, I hope. We're probably going to need to copy these over to generation as well. Where are we? Generate, scope, return 4. Generate 4. Yeah, so this here is exactly the same. This is a bit weird. It's like out of order. But that's what it's supposed to be. Yeah, because we need to do this is the body of the for loop, and it's after the body of the for loop that we need to have the post statement, we call it. You know, in our for loop, I don't know if I've got here, this statement here needs to happen at the bottom, right? It happens after, at the end of each iteration of the loop, we do this. So it makes sense that this goes at the bottom. It is, however, a statement, so we can't check like that. I think we can, again, check based on the index should be able to do this. There, let's try that. See if that works. And then we can work on some of these type things. So disallow redefinition of type. That's where, like, if I had something, let's go to the top somewhere. If I had something like foo I64 equals 1, and then I think currently I could go foo I32. Oh, we're all golden. Everything's working. Currently I could go I32 equals 2, like that. And this would be wrong. So unfortunately, I'm going to comment these out again. They just take too long to run. So what would it say now? Oh, it succeeds. I'm kind of surprised because I thought type checking did something about that. I noticed something in type checking, which is what made me kind of think to do this. Where is it? I guess it's an assignment. It's left-hand side. So if the value on the left-hand side is in identifiers, which should be the case on this line, right? This is in identifiers, and it has a different type. So we get the type, and we coerce it with the type from the identifier node. And if the coerce fails, then we should get into compatible types. So I'm kind of surprised that that's not happening. But actually, what I want to do is basically say you cannot do this. So this is after type check primary. So is that already kind of wrong? Because we want to know, like, did someone manually put the type there? This type check primary is probably going to put the correct type. So it's going to have duplicate types, which is probably why there's like an issue. If we do it like that way around, now maybe we'll get the error. Yeah. Okay, so that was already wrong. This, I can also see that this is probably like, should be not a member. And yeah, we don't have like a get node value because this is also kind of implying that this node is an identifier node. So I guess if it is a member or it's in here, those are the situations where we don't want to have a type on it. So I think we just say if get type does not equal nil. I think that's all we need to do. We just need to say it. So maybe we can even just put that. No, we'll leave it like that. So if we're looking at a member or something that's already been, is it already a known identifier, we can't specify the type. That's what I mean by we can't redefine. So the error we'll get instead is like, you can't do this. With the current code that we had, you could have done this and it would have still been valid. Like there wouldn't have been a problem with that. But it makes things a bit ambiguous because what if you've got like a lot of space between here and then you're like, oh, I want to define foo again, or you didn't realize that there was a foo up there and you define it here, there's still problems like, what if it was not, sometimes you don't need to specify the type. So I'm toying with the idea of forcing you to do this if it's a new one. Anyway, right now, what I want to do is make it so that you cannot do this, and you cannot even do it if it's the correct type. So, fail to type check left-hand side expression, and we say cannot redefine type of, and we say no dot value. So that should give an error. Cannot redefine type of right. Okay. And line 1, column 1. And that's because, interesting. That's because procedures are already in, they're already in the identifiers when you go to type check. So should we just specifically exclude them? It's because at the top here, we have this loop that goes through, see, and it puts the procedures in the identifiers. So then when we come down here to do the type checking, it's already there. And then when we type check this, it's like, hey, you can't redefine this type. So it starts to make me question, like, disallow redefinition, is that really what I want? Or is what we had before actually fine? Well, what we had before I don't think was actually working properly. Like it was not working for members, and I think it gets more complicated to be able to check. So I think it is good to just like not allow it. So maybe I think we're just going to have to make a special case for procedures. I think that's what we're going to have to do. For static procedures. Yeah. So if it's a procedure and static, where are we? Type check assignment, type check left-hand side. So we've not, okay, so we can get the type node. Like so, and we're saying type node is not equal nil, and type node is not that, or does that sound right? So there is a type, but that type is either not a procedure or it's not static. So if it is a procedure and static, then this will resolve to false. And we won't get the issue. So I think that should exclude for procedures. Yeah, cannot redefine type of foo. So even if I make it the correct type, it should still complain. So if I take the type off, now it's happy. Okay. Yeah, I just wanted to kind of, so that was broken before, and now it's we've fixed it up a bit. I kind of don't like that we have to have the special case, but that's okay. Okay, so I guess we can like cut these out, cut that out. Very good. We're only 35 minutes in, so let's take a stab at some more. Negate only numerical types. I think this is quite easy, actually. Oh, wow. Negate. See, right now I'm saying you can't negate arrays or slices or references, which is not strict enough, because then you could negate what, like strings and bools and yeah, things that don't make sense to negate. So I think what we really want is to check if it's a numerical type. Right? And if it's not a numerical type, then you can't negate it, right? So if I revert to the old code and put the new code there, but we'll just comment it out. So in the old code, I guess you could do like, see like foo equals false, bar equals negative foo. And it compiles and everything. And probably, so false is 0, negative 0 is 0. It would be, the problem would be this, because now bar would be negative 1. Which I guess is actually not so much of a problem, because when it comes to true or false, when we do our checks, it's basically 0 is false, non-zero is true. So it's still evaluate to true. But it just doesn't make any sense to be able to do this. Look at my frame rate. The performance on this laptop is just so random. Yeah, now we got, okay, yeah, I don't know. So we want to disallow this. And I think this should do the trick. This new code. There we go. Cannot negate type bool. Good. But we do have other negations in this code, and they work fine. Okay. Great. On to the next one. Allow reference of reference. Yeah, this was kind of in the same area. Previously it was disallowed, but I don't really see a reason to disallow it. So I'm not going to. So I think you can take a reference of anything. I guess what you can't take a reference of is a literal. Yeah, you can't take a reference of a literal. And a literal is string, C-string, number, Boolean, compound literal, nil, all of these. Oops. So if we go to our AST, let's say literals. I copied way too much stuff, but and now it's actually going to be hard to find the individual literals, but here we go. And this one. Okay. I think that is actually all of them. Boolean, C-string, compound literal, nil and number. Yeah. So that's all the literals. And it was in type checking. So really I want to do something like this. Literal literals. But it's not the type node we're after, is it? No, it's not the type node. It's the node. Yeah, node type. So it's like node children 0.type. And if it is a literal, that's bad. You can't reference it. So, so as an example, if we say foo equals a reference to true, that should not be possible. Oh, cannot reference type. It's like cannot reference that. Cannot reference Boolean, I'll say literal. Yeah, cannot reference Boolean literal. Great. Or if I go 5, it will say like number literal. Yeah. But if I say like this, that should be fine. Yeah, that's totally fine. I can reference that because that's a variable. Just not literals. Okay, cool. So that's an improvement. Not quite the improvement that I was expecting in the beginning, but I think that's better. Well, I did allow references of references, but I also did some other restrictions which are better. Improve type names for structs and procedures. Yeah. So the thing here, if we do another example, if we say foo is a struct with a member I8 and bar is a proc with the parameter I8 and maybe an I8 return. And then we say, hey, I want to assign bar to foo. That should not work, right? We should get incompatible types. And we do, but we just get like this procedure in square brackets and struct in square brackets, and that's not very nice. So wherever it, wow, geez. This is exactly where I wanted to go. Wow, that's, yeah, it's pretty impressive. So maybe we'll start doing a switch, hey? The good old switch. And the first case can be array. In the case of an array, we return that. And in the case of a slice, we return this. Now we want to do the case of a struct. Now, how would we print out a struct? Well, I do believe, I guess we have the prefix. We don't just have a single child, we have multiple children. And we also start with struct opening bracket space, I guess. And then we have a closing bracket at the end. And I guess for like child names, child type names, which I guess will make a dynamic array of strings. Well, ideally we would just want a string, right? I don't know if we can do, does he have like a join? He does have a join. Okay, yeah, that's probably easier then. So this would be like strings.join child type names with a comma space. Yeah. Okay. But I guess we need to change that to a slice. How's that? Okay, good. Now for member node in type node, we say child type names we append to child type names. And it's like member node dot value equals let's type node dot children equals and then we recurse, right? We say type name of get type of member node. So member node needs to be a pointer. I believe that's correct. Let's see what happens. There we go. That looks good, huh? So incompatible types, some procedure and struct with this member. But instead of that, actually it should be colon, right? For the type, yeah. Beautiful, okay, good. Yeah, that's exactly what we have here. So now we want to produce this for the procedure. We'll put these in. I don't have any other opinion about ordering, so we'll use the alphabetical order, which is my default go-to. So here we want to say proc bracket, and there's closing bracket. Yeah, and we might have a return type to put here as well. I guess we'll get to that. But these are the param node. So param type names. I guess we can call these member type names. So param type names, but first we need the params type node, which is the first child. And then the param nodes are the children of that. That's how procedures work. And for each parameter, yeah, we want this. We want the same setup. So it's just param node. So I think that should do that part. Yep, we have proc parameter i8, very nice. And now we want to optionally, so we go like return type name. There's a string. Put that there. And we say if the length of type node children equals 2, which is to say if there is a return type, then this guy equals basically the same as this, right? Same thing. But with the return type node, which will be child 1. And we need that to be a pointer. But we do want at the start space arrow space. Oh, we don't need the value. It's just a type. Just a type. Ooh, it did not like that. Because this is already a type node. There we go. Incompatible types. Procedure that does that versus struct. So those look a hell of a lot better. Pretty happy with that. So we can cut that out. We still have time, 52 minutes. But these guys here, I feel like they're quite big things, so I don't want to get stuck into them too much. We could potentially do this, but no. We will not. We won't get into these either. So maybe we just do some cleanup, eh? Could we try the gdupe? Data section gdupe. Or we could separate the files. Those are the two that I'm thinking about. Let's do the gdupe. I think that's a nice thing to do. So I think it starts in here. So this is where like we add to our, we have these lists and we create a name, f32 underscore something something. And what do we create the name from? We just use it kind of like an index. So instead of that, I think what we're going to do is we're going to say yeah, and this in these strings, this also needs to be improved. So what would be the easiest way to do this? Like when I was looking at here, I was thinking maybe we can, make the, so if we were wanting to store 0.1, maybe we could just do 0p1, something like that. That works for these floats, but for these strings, we're not going to put like the whole string in the name. We could do like a hash, but then there's a potential for hash collisions, So I'm not so excited about that. I don't know that stuff so well. So my confidence is low, which makes me lean towards like just using indexes for names still. But I guess the difference would be that first, before we append a new one, first, let's check whether one exists. Yeah? So we can look through here. So if we go data section string and let's go string name in. And then we can say like, if this, can I just do equality with strings? What is the string? This is the string. Does that work with strings? String conversions. String type. String print formatting, C string type conversions. Operators, arithmetic. Oh, so this is like a whole new section, operators. But I kind of want to see like comparison operators equal. Okay, string values are compared and ordered lexically byte-wise. Okay, great. So I think that's what I was trying to say, is that this equality operator is going to work the way I want it to. It's going to actually compare the two strings. So if it finds the string that it's looking for, then we just return that, right? We already have a string name. Is that basically it? It's an array. So this is the data section string, and we give an index, and so I guess we don't actually do that. I guess we say index equals the length of the strings, unless we find an existing one. And then we say index equals so let's say existing string and existing string index. And that's what we put here, string index. And we can break. So then we create the string name, which is just for that. And I guess we can say, you know, if string index still equals this, yeah, so that means if it still equals that, it means we did not find an existing string. So we add the string. Only need to do it then, and then we can just like create our new name and return it. Or it might be an existing name. Okay. All right, and this here is the assembly we're in question. So I don't think there are any duplicates in here right now. But if we do a trusty example, like foo equals hello, and then bar equals hello, we look at our assembly, we see hello, but we only see it once. And it's string 0. So if we look for string 0, yeah, we can see that they're both get assigned from string 0. So that's perfect. So I guess that's basically what we need, but that's quite a lot of code, and I don't want to duplicate it like 4 times because we have 4 different lists of things. So I'm wondering if we can like extract this and maybe even this as well. I think we could extract this whole thing. Yeah. So it's like it's kind of like get data section location. I don't know if that really makes sense, but kinda. So maybe we'll even return a location. So we need a dynamic array of strings, which is our data section values. So that replaces this data section values. So it should be a pointer because we're modifying it. Data section values. So let's say index. We can say existing index, existing value. String index. Damn it, I should have done copy and replace. Let's do copy and replace. Existing value, existing index, like so. So that's our name. So we need a prefix also. Call it our prefix, so that goes there. And then this node value. So prefix, so let's just go value. So we don't need node.value, it's just value. Okay, so we're getting there, it's not type checking, it's just back here. And then, so just to finish it off, because I'm calling it get location, so let's return location, just like that. Okay, so I think that's basically kind of a more generic version. And I should be able to just say, oh, but this is returning memory. This one's returning an immediate. So this is like, this is the really weird thing. So maybe we don't return. Maybe it's just name. So we'll just return a string. A little bit worried about this because we have like this whole temporary buffer thing going on. But we do this concatenate, so that's going to allocate a new thing. So let's just go. I think this is going to work. Okay, so here we're trying to get the name. Whoops. That goes in there. And what do we need to do? We need the data section values and the prefix, I believe, and the value. Like that. Boom. So here we need to make an immediate, which means we don't need that extra parameter. And this is with C strings. And so it's the C string thing. Boom. And everything else is memory also. So this has F32. Boom. Very nice. And this is F64. Boom. So that should deduplicate everything. So I think we have, if we go down here, see there are some duplicates of the F32s. So that should get removed. But we have an issue because why? Oh, because we need to pass a pointer to that, I think. There we go. So that seems to be running. And look, we don't have duplicates anymore. So that, yeah, there's 3 instances of that getting used. Okay, so we deduplicated our static variables. Done. And we're at an hour 7. So I think that's a good time. We just like nailed a whole bunch of stuff. So that's really cool. We still do have, these are going to take a bit of time. We still do have these to like sort out. But once we have these sorted out, and these, I'm not so worried about these right now. But if we sort out these and these, man, I'll be pretty damn happy with the languages at then. I'm already pretty happy, but I think these things are going to make it like really nice. I feel these missing. This is annoying how you have to index with an I64. Return values are a mess. And modules would just be really nice to have. Cool. All right. Thanks for stopping by. Have a good one. Ciao for now.